Hey guys, so today we're going to talk about identifying and graphing sequences, but before we do that we're going to go over graphing functions with a given domain. So I'm going to write down this example and then we'll solve it together. Okay, so the thing with this is it is a regular function, except as you can tell, this is written in another form. So what we're gonna have to do is you can totally keep it in this form and then just solve for each domain value, put it into the x, subtract it from the 20, and everything. Or what I like to do is I like to separate the y and bring it back to the mx plus b form, because this is the standard form, but I prefer the mx plus b equals y. So that's what we're gonna do. So first we're gonna take this 3x and add it to both sides so we can try to get the y alone. Now, as you can tell, the y has a -5, so we're just going to divide it by -5. And remember, not just the 20, not just the 3x, the entire thing by -5. So now when you simplify it, you can bring the 3x over -5. Also, as you can tell for this, that same thing is equal to 20 over -5 plus 3x over -5. That's what it's equal to. It doesn't go for the whole thing. You can separate it into two fractions, which is basically what I'm going to do now. So now, as we separate it, we can bring out the -3x over 5, because the negative just comes out. That's just how it works. And then, because this isn't 20 divided by 5 is actually 4, and as I explained before, dividing a positive number by a negative number gives you a negative number, so 20 divided by -5 gives you -4, so -4. So that is the function in terms of mx plus b, because the x is right here and this is the b value. So I am going to pause the video and write down, or you can pause the video and write down all of the domains and ranges for each of those values. So I wrote them all down here, and all we're going to do is graph them now. So the domain, -10, -5, 5. And the range, -7, -4, -1, 2. Okay, so the 10, it goes with the 2. I think I said -2, I meant 2. The -5 goes with the -1, which is like around here. I'll just draw it there. This goes here, this goes there. So you can tell it's a line, sort of. Just put arrows on the end because this line is continuous. So that is how you get the graph. You can change it to mx plus b, your total preference, dependent on what the question says. Sometimes the question will say keep it in standard form and solve it, so you just keep it in this form. Or if it says change it to mx plus b, you change it to this form. Okay, so now I don't like this next unit, but it kind of is required to know, just in general for math knowledge. So identifying and graphing sequences. So sequences, like a sequence is just a list of numbers in an order. So it's not complicated, but each element in the sequence is called a term. So for example, I'm going to give you the sequence 1, 3, 5, 7, 9. These are all odd numbers. And so this is a sequence, but these individuals right here are called terms of a sequence. So all you're going to do is, it's like a regular graph. It's domain and range, except Both of them are sequences for the domain, and there's a sequence for the range. It's that simple. So the first thing we're going to talk about is I'm going to give you an example. The total cost, which is the term, of riding a go-kart for 10 numbers of laps position is shown below. Complete the table. Okay, so it is just the function where, let me just draw this table. Okay, it's a little messy. Okay, so this is position number in terms of n. So always sequences are in terms of n. There is no x and y. Obviously, we can tell that these are the x and y values, except we just don't call it that. Term of sequence, as we said before, f of x is equal to the y value, but instead of having an x, it would be an n. So f, function of n. So these term values are going to be 1, 2, 3, 4, 5. So 7, 9, 11, 13. So if you don't recognize the pattern, that's totally okay. So all that this pattern is now we are going to have to write a function for this. So what do you identify in this? The first value is being multiplied 3 times, and then it's being, oh, sorry. The first value is being multiplied twice, and then it's being added by 5. So it's just f of n is equal to 2n plus 5. So this is the sequence function for the terms of the sequence. Okay, so now the next thing we're going to be talking about is the explicit versus the recursive rule. So the explicit rule for a sequence defines the nth term as a function of n for any whole number n is greater than 0. So I'm going to give you an example of the explicit rule. So the f of n is equal to n squared plus 2, and all they want you to do is make a little table for the f of n versus the n values. So we're going to call this n and f of n. F of n in this case is defined by n squared plus 2 because that is the function right here. So we're just going to find f of n for each of these values, 1, 2, 3, and 4. So for the first one, 1 squared plus 2 is 3. 2 squared plus 2 is 6. 3 squared plus 2 is 11. 4 squared plus 2 is 18. Okay, so now, as you can tell, the first 4 terms of the sequence have been defined by this explicit rule, n squared plus 2. So that is just the basis of the n squared plus 2. Now I'm going to give you a question, and we just have to find what n is. The number, let me erase this 1 second. Okay. The number 125 is a term of a sequence. 125 is equal to the term, okay, of the sequence defined by the explicit rule. They have given us the explicit rule, so oops, I'm so sorry. 3n plus 2. Which term in the sequence is 125? So what they're asking is the term as I described before, sorry, I don't know what that was. As I described before, was that the term is the y value or the f of n. So they're saying in this equation, f of n is equal to 125. So all we're going to do now is solve for n, or yeah, we're solving for n. 125. Same thing we did with the x values, except we're doing it in terms of n. So first we're going to make the n alone. Right here, the n's right there, minus 2. So it's 123 is equal to 3n. Now you just divide this by 3, and n is equal to 41. Okay, so that was a little basis for the explicit rule, and now we're going to go to the recursive rule. So the recursive rule for a sequence defines the nth term by relating it to the previous term or the term in front of it, or even 2 terms behind it. It really doesn't matter. That's how it's related. So I'm going to give you a little recursive rule. It's a little longer than the explicit rule, but it helps to relate to the other terms in the sequence, so it can be easier to solve for. In case you're looking for the recursive rule versus the explicit rule. Okay, so now we're just going to do it in terms of 1, 2, 3, 4. Sorry. Okay. Okay, so the f of n, we are going to solve for it now. And since this is the f of n, you plug in 1, and then it's 1 minus 1 plus 3. So instead of doing math, they always give you the first term of the sequence. So they gave to us that this is 2, so now we need to find 2, 3, and 4. So for f of 2, what you're going to do is do f of 1 plus, let me write it down here, f of 1 plus 3, so that's 2 plus 3, so that's 5. So now we're going to do that, except we're doing f of 2 plus 3 is equal to 5 plus 3 is equal to 8. And I'm just going to write the next value. Okay, so this is the first 4 terms for this recursive rule. So there are so many practice problems in the book, which I honestly think are wonderful. So I'm going to do one of the examples with the given rule. So we have f of 1 is equal to 7 comma f of n. It's equal to negative 4 times f of n minus 1 plus 15. That is a little long, but as you can tell, they've given us this first value because it's mandatory. Because you can't, as I said before, this is the recursive rule if you didn't notice. So the thing is, with the recursive rule, it is dependent on the previous term. So if you don't know the first term, then you literally cannot solve for any other terms. Okay, so now they want us to find f of 2, f of 3, and f of 4. So f of 2, question mark, f of 3 right here. Okay, so all we're going to do, same thing we did last time, except for the f of 2, we're going to do negative 4 times, so the f of 1 is 7, so negative 4 times the before term, so f of 1, and then you add 15 right here. So in this situation, you would need to use PEMDAS because it's a little complicated if you don't do it right. So this first example right here is equal to negative 13. I personally don't know if you're allowed to use a calculator, but I would suggest maybe try and get in your head just so it can be a little easier if you aren't allowed to use it on a test. So for this next one, you would take negative 4 times the previous term, so f of 2, which is 13, negative 13. So negative 4 times negative 13 is 52, and then you add 15 to it, so it's 67. Again, same thing, except you're taking f of 3 because it's the previous term, which is right there. And then you add 15, which is equal to negative 253. Okay, so these are the first 4 terms. You can just write it down in a table and prove to them that you solved them. Okay, thank you guys so much. I hope you all have a wonderful day.